So the agenda for this presentation is the following. I will start with showing you the deployment architecture of Ocean Enterprise Technology Stack. Then some questions that needs to be addressed when you plan to deploy a data space based on Ocean Enterprise solution. Then I will present you the hosts and the reverse proxy configuration that we will use. We'll go through the prerequisites needed in order to run the components successfully. Then through the deployment steps needed to perform, and finally the demonstration, the actual demonstration. Okay, so beginning with the deployment architecture, a data space enabled by Ocean Enterprise has many components. As you can see here, there are 7 components needed. The OE market is basically the front end in which all transactions will be performed, publishing assets or consumption of the assets. The OE node is the heart of the system. It enables the encryption of the assets, the retrieval of the assets, as well as the value transfer between providers, between asset publishers and asset consumers. And then there are many components needed to implement the SSI policy verification, such as the policy server, the verifier, the open policy agent server, policy server proxy, and the SSI wallet in which the verifiable credentials and the deeds are saved for each participant to the OE market. Next on the agenda, so before starting to deploy the technology stack, you need to answer some questions. For instance, what blockchains will be used to store the asset information? In our case, we will use Ethereum Sepolia. Another question would be, what currencies will be used to price the assets defined in that data space? We will use the EuroC from Circle. Will the data space provide a compute-to-data environment in which jobs can be executed? Yes, we will provide such an environment. Will the data space provide the data space C2D environment provide GPUs? Yes, we will use some mock-up GPUs, and you'll see how this works. Will there be a free C2D environment to run some test jobs just to see that your computer data jobs run? Yes, we will use such a free environment. Which are the nodes to which the market will connect? Probably you know that currently the marketplace supports multiple nodes to which it can be connected. In our case, we will use just one, this that is listed here. And then maybe some questions related to the fees that are charged for asset consumption. There are multiple types of fees that can be enabled in the marketplace. One is at the provider level or at the Ocean node level. And in our case, the provider will charge €1 per asset consumption. And there will be also fees enabled in the marketplace. And here we have 2 types of fees that will be enabled: a fixed fee of €1 for per asset consumption, and a variable fee of 10% of the asset price. Will there be SSI verification enabled? Yes, definitely we will use SSI verification in our data space. Moving on to the next chapter, here we have the hosts and the reverse proxy configuration that we will use. Basically, all components will be deployed on for virtual machines. The entire SSI stack will be deployed on VM9. the policy server and policy server proxy will be deployed on VM8, the node VM7, and the market on VM6. They will not be exposed directly in the internet, but they will go through a reverse proxy. And on the right side, you can see the the host name by which every component will be accessed through the reverse proxy. So this is a best practice to place all components behind the policy server proxy, and this is also documented in our documentation as one of the steps that need to be performed when you deploy the components. Moving on, what prerequisites are needed to run the components? Mostly these are related only to the OE market and OE node, and are the following. There, you should have an RPC provider, which is recommended to be a paid one. The RPC provider will enable the market or the node to read blocks from the blockchain. The free tier usually it's very limited in capacity. That's why we recommend to use a paid subscription. And this will influence you the number of blocks that the indexer within the OE node will read. And also, it's very important for you to set up the starting block of the of the blockchain. So basically, this is the block from which the indexer within the OE node will start reading to identify assets that have been registered within that data space. And the next requirement is to have an IPFS provider. The IPFS is used by the node and by the marketplace to store the asset video. That's why you need to have such a provider. And for this IPFS provider, you need to have a gateway URL, an upload URL, a delete URL, and the JWT, the secret that will be used by the client to write in IPFS. It's very important to use a public gateway, at least on the node side, because otherwise the node will not be able to access the files on IPFS that were written by the marketplace. Moving on, deployment steps. We will begin with deploying the SSI stack. Following will be the policy server and policy server proxy, then the node, and finally the marketplace. All the steps are documented here in this on the OE documentation site, which is linked here. Okay, then let's go to the live demo. I will stop the presentation and switch to the command line on one side and to the documentation side on the other side. So deployment guides, we said that we will start with the deployment of the SSI stack, which is here. It will be deployed on our virtual machine VM9. So let's go through the steps first. Okay, there are some requirements related to the hardware on each. The SSI stack should work at least 4 gigabytes of RAM and 25 gigabytes of disk. Let's move to deployment. We'll start by cloning the repository, which we already did, and now we are in the Vault ID identity directory. Okay. Then we need to use a certain branch on the SSI stack. And just let's see if we are on the OE branch status. Yes, we are on the OE branch. Then change the current directory to Docker Compose. Move to Docker Compose, and everything we need to do with the SSI stack is just start the services. So Docker Compose minus D. This will build the containers and we start all containers. Okay, this command does not start the OK server, which is used by the verifier to check dynamic policies. That's why you need to start it manually. So Docker Compose up OK server minus me. Okay, we start the container. Now just a quick verification that everything is started. Nothing. We can see here that the OP server is started. The wallet API is started. The verifier API is started, as well as the user interface of the wallet. We can run a very quick check to see that these components are accessible. So if we go here, this is the UI of the wallet. This is the wallet itself, the wallet API, which is accessible. And here we have the verifier that use, and here we can just perform a very quick verification that it works. So we just initialize a presentation session using the default verification, which just requires an open badge credential. Execute, and we see that the verifier returns a presentation definition that can be used by the wallet to perform verification. So that's everything that needs to be done on the SSI Stack side. Now let's move on to the next component, which is the policy server proxy. For that, we will go first to this page on the documentation, policy server and policy server proxy installation and configuration. And we will switch to another virtual machine, which is VM8, on which we will deploy both components. Because we didn't have enough machines, we choose to deploy the policy server and policy server proxy on the same machine. But this is not a very good practice. Normally, it should be deployed on different machines and placed in different networks, security areas. And maybe in another session, we will explain what would be the best approach to separate the components just to increase the security. Okay, let's see what we need to do on the policy server side. So basically, we will deploy policy server and policy server proxy. It is the same component, the same software component, which can run into different modes. The policy server itself performs verifications coming from the Ocean node, and either allows or denies the specific action. And for that, in some cases, it employs the verifier, which we just deployed earlier, while the policy server proxy intercepts some requests coming from the wallet and forwards them to the node just to to complete the whole SSI verification. That's why we need to deploy these two components. So let's begin with deploying policy server. First, we will use Docker Compose to install and run policy server. Sorry. Okay, so first we need to clone the repository, which I already did. Then we need to switch to Docker Compose. Here we have an example of the environment file that needs to be configured. So first, normally you need to copy the environment file, but I already have one prepared in a different directory, and I will show you how you need to configure it. Okay, so basically what we will do, sorry, we will okay, it's in this directory training. Here we have two environment files, one for the policy server and the other one for policy server proxy. We'll start with the policy server first. So let's see what we have in here. In this environment variable, we need to configure the following. The authentication type will always be Vault ID, because this is the SSI Stack provider. In our case, we use the software coming from Vault ID. Then you need to configure the Vault ID verifier URL, which in our case is this verifier training oceanenterprise.io. Then you need to specify the URL of the Ocean node that will use this policy server. In our case is this Ocean node VM7 oceanenterprise.io. The next two environment variables refer to the URL that will be sent back to the client when a request is made by the client. And in case it is a success, it will return this redirect URL with success and then the session ID. In case of error, it will return this URL with the error and the session ID. And based on this URL, the customer or the client can decide what to do next. Then it's what else needs to be configured. There are two redirect URL. Basically, that needs to be configured in the following way. Here we place the URL of the policy server proxy, followed by verify and session ID. This is to for the verify response redirect URL, while for the verify presentation, we use the same policy server proxy URL, followed by /pd/session ID. So everything you need to do here is just to add this part of the policy server proxy URL. The next two variables refer to the policies that will be automatically executed by the verifier when a verification comes from a customer. And these are predefined. So expired, signature, revoke status list, and not before are automatically added by the policy server to which request that it receives. And then it's passed to the verifier. And basically the verifier will add these verifications when it checks if the customer is allowed or not. Then enable logs. If you want to see what happens with the policy server, you can enable logs, as in this case it's set to 1. If you want to disable it, just set it to 0. Then the following two variables explain in which mode this component will run. Will it be a proxy, a policy server proxy, or it will be a policy server, just a policy server. In our case, this will be the policy server, not the proxy. Yeah. And the port, just leave it 3000. Okay, let's copy this environment variable to the policy server directory. Copy them to site. Okay, let's go there. We have the M5 here. Then let's see what else we need to do here. Start start the policy server service. So basically everything we need to do here is just Docker compose up minus v. Okay, now the policy server started. And it started on port 8001 of the host server. Let's see if it is accessible. Policy server. Yeah, this one. One second. Comes around. Okay, one second. I don't know why this is not enabled in the. So it started, but somehow is not enabled in the reverse proxy anymore. So this is our policy server, and let's give it a try if it works with the verifier. Try it out. So basically, what we do now is we run a verification on the policy server side, and the policy server side will go to the verifier and retrieve a presentation definition. So you see here, this is the presentation definition that is retrieved from the verifier. So that means that the connection between the policy server and the verifier works fine. Now, what we need to do is to install the policy server proxy. Sorry. Okay, so let's go back to documentation. And to do this, we will perform the other type of installation using just Docker, because we'll do it on the same machine. So, moving to the training directory where I also have the configuration for the policy server proxy. Let's just quickly review it. This is the same as for the policy server. It's just that I enabled the proxy mode and I disabled the server. We will start this on a different port on 8100. Okay. No. So let's copy first the file. Mm, okay. Okay, the file is here. Then let's run the command. Uh, okay, so we have this container, policy server proxy. We will use the environment file that I just copied, .env -psp. It will run on port 8100, and we'll use this Docker image. Let's start it. Mm, one second, I'm doing something wrong or what? Okay. So now I have the policy server available here. Let's see if this works through the no. Then at least let's try to enable it through directly through the host. Yeah. So looks like there's an issue with the policy server with our reverse proxy, and the requests are not forwarded to the hosts. Okay, we don't have to perform anything on the policy server proxy because its purpose is just to pass through some requests coming from the wallet to the to ocean level. Okay, then let's continue. So we deployed the verifier, the wallet, the policy server proxy. Now let's move on to the node, to the OE node. And this is on a different machine. It's on VM 7. Okay, then going here in the documentation, OE node installation and configuration. Um, yeah, the software requirements, operating system, and the Docker range in Docker Compose. Other requirements, as I mentioned in the presentation, we need to have a blockchain RPC provider and an IPFS provider. We used Alchemy for blockchain RPC and the Pinata for IPFS gateway. Again, I insist on this point that the IPFS gateway configured in the node should be a public gateway. Otherwise, it will not be able to retrieve the files that were pinned by the market. Let's see how we deploy it. Okay, so we start with the usual cloning of the repository, which we already did. So if we go here, we have it already cloned. Then Ocean Node uses Elasticsearch for storing the indexed assets. So we need to also run a Docker container for Elasticsearch, and this will be used by our node. That's why we need we have two configuration files, one for Elasticsearch container and one for the node container. So what we need to do first is to copy the environment file for the node, this environment file example into this file. But again, we already have that prepared in the training folder. Okay, so if you take a look here in the environment file for Elasticsearch, everything we need to set here is the password for accessing the Elasticsearch. Okay, normally you should use a different password, not as simple as that, but yeah, this is how you should do it. Other options here, I don't usually change any of them. Maybe security. If you enable security, then in the URL string to connect to Elasticsearch, you need to also include the username and the password. So this is everything you need to configure in Elasticsearch environment file. Okay, and then we will copy it to the Ocean Node directory. Then we need to set up the environment variables for the node, and we'll do this in this .env.node file, which again we pre-configured for you just to go through it more easily. So let's see what we have here in this part. Not this part, because there are some keys that some secret keys. I prepared the sanitized version of this file with the keys removed. Yeah, maybe I should have removed the. Oh. Yeah. Anyway, here you have the private key of the node. Then in the RPC, you need to specify the URL that you use to connect to the RPC provider for this chain, which we already mentioned that we will use. So this is Sepolia, Ethereum Sepolia. Yeah. The chunk size mentioned how many blocks will be read at once by the indexer, and the start block basically specifies where with which block it should start the reading for the assets. I updated this today because this was the most recent block in Sepolia when I verified it. Then, what else we need to specify? For Elasticsearch, you need to specify the URL to which the container is the Elasticsearch container is available. In our case, because they are in the same Docker network, is Elasticsearch on port 9100. The DB type is Elasticsearch, the username and the password. Then, for IPFS, you need to specify the URL of the IPFS gateway, which was provided by you when you registered with one of the IPFS providers. As I mentioned, we use Piñata, but there are many others that can be used, and I think I listed them here. Piñata, Cloudflare, Firebase. So you choose. Then the Arweave gateway, which we, in our case, is the default one. What else you need to specify? As I mentioned in the planning part of the presentation, we will charge the node will charge 1 EUR/C per asset consumption. So in these parameters, the fee tokens, you specify which is the currency used for fees for this network. So for Sepolia, we will use EUR/C, and this is the contract address for EUR/C. And then you have to specify the amount, what is the value of the fee, and it's 1 EUR/C basically. The measurement unit here is not yet implemented in the node. It is defined, but is not used by the node. That's why it is charged only per asset consumption. But probably in the future, it will be implemented to charge, for instance, per megabyte or per gigabyte of transfer. Then moving on, we have the HTTP port on which the node will run, which is 8000. For SSI, since we configured SSI verification, you have to specify the policy server URL. In our case, is this one, ps.training.oceanenterprise.io, but because our reverse proxy does not work, I need to update it to the one that we used here. So basically, I need to copy this. And paste. Okay. Next, on the node configuration file, if you want the node to expose a computer data environment, then you need to enable this in this Docker compute environment variable. And I will show you very quickly how the information here looks like. So this is basically the value of that variable. Payment claim interval mentions when the node will claim the money that were locked for running a specific job. The resources that the node will present are listed here. Here you have to specify only the GPUs if you have GPUs, and you need to define the driver used by the node in order to access the GPU, and how many GPUs are available there, and the disk, because the processors and the RAM are read automatically by the node and presented in this in its configuration. Storage expiry, maximum job duration means how long a job can run in this environment, and it's expressed in seconds. So basically, for this environment, we can run a job for an hour. And then, what are the fees applied? For Sepolian blockchain, we will use again EuroC, and the following prices are charged. For per GPU, it's 0.1 EuroC per minute. For GPU is 0.4 and so on. Yeah. We also mentioned that we will provide a free environment, which is free of charge and can be used by anyone. But of course, it has limited resources. In this case, the maximum job duration is half an hour. Yeah. It can run simultaneously only 3 jobs, and the available resources are is just one GPU and a maximum number of CPU and half a gigabyte for RAM and half a gigabyte for disk. Basically, this is set in this variable here. Then, what else we need to set up here is if you want, and it is recommended that you set the node owner information, so who runs the node, so that the customers, when they are accessing the node, they are informed about who runs it and what are the terms and conditions applicable when using that specific node. Then you have to provide the Web3 address of the administrator of this node. And basically, these are the most important environment variables that needs to be set for following node. Yep. Okay. Then yeah, I guess I need to save it because I changed the actually I don't have to change it here. Yeah. Then we need to copy the file to Ocean Note folder. So let's copy. Okay, then let me just 1 second, because I need to change something in the file. I showed you the other file, but I need to 1 second. So I just need to copy in the policy server URL. Paste. Okay. Then so now I have the file in the Ocean Node directory. I have the node and I have Elasticsearch here, configuration files. So now I can switch back to the deployment guide and see what else needs to be done. So we copied the environment files and now we need to start the services. Docker compose app -d. Now Elasticsearch is started, and the node waits for Elasticsearch to get into a certain state in order to start, because otherwise it will report errors, and it will take a while to start, like about 40 to 60 seconds. Takes even longer. Yeah, so it started. Let's see that the services are running. Okay, so we have Ocean node Elasticsearch running on 9200 port, and our node running on this port on 8000. Let's see if it works through the 4G server proxy, because normally now we have to access it through here. Yeah, it looks like this one works through the 4G server proxy. So now I just queried uh, the new node. Yeah. And if I want to, for instance, here you can see the imprint for this node, social enterprise collective, details, terms and conditions, privacy policy. And if I want, for instance, to see the computer environment exposed by this server, I can see here exactly what is available. Yeah, basically what I defined in that environment variables now is accessible through this endpoint on the node side. Okay, so now we have the node running, policy server running, the verifier running. Now let's continue with deploying the marketplace, which will be on another machine on VM6. Okay, so going back here to the documentation site. Let's select marketplace installation and configuration. Again, we need a blockchain RPC provider, an IPFS gateway provider, and yeah, the node operational, which we just verified. Deployment steps. First, clone the repository, which I already did. It's here in the market directory. Then again, we need to edit an environment file. You can copy the example, but as I mentioned, we already have one available in the training folder. Okay, and let's see what options we set in the marketplace configuration file. Okay, so what do you need to configure here? First of all, you need to configure the node or the nodes to which that marketplace instance will connect. So there will be a default node provided in this variable, public provider URL, and in our case is available at this URL, Ocean Node VM7 Ocean Enterprise IO. Then you need to specify the metadata cache URI. What does it mean? It means in which node are the assets located. In our case, is the same node. Yeah, so basically the metadata cache is of this node that was defined here. So we have basically the same URL. Then you can define what other nodes the marketplace will connect to. And connecting to a node means two things. One, the marketplace will list the assets available that are will list the assets for the nodes that are listed in this variable, and also the marketplace will allow a publisher to create an asset on one node that is listed here, on all the nodes that are listed in these environment variables. And as you can see, this is a list of URLs. So basically here you can add more if you want. Yeah. Okay, then what else we need to specify is the blockchain RPC that you are going to use. And you have to specify it per blockchain. So for Sepolia blockchain that we use, here is the provider that is used. Then for IPFS, you need to provide the gateway through which you access the saved files. Then the upload URL and delete URL, these are specific to each IPFS provider, IPFS gateway provider. So for Piñata, these are the available URLs. Then IPFS JWT is the key used by you in order to access the provider to create files in IPFS. And as I mentioned before, we save the assets DDO in IPFS, and then we reference this file in blockchain. This is how it works. First, we create the DDO in IPFS, then we use that ID of the file created in IPFS and add it in the blockchain. Okay, public unpinned files. In case you delete a file, then it will be automatically unpinned. Then another section in this configuration file, currencies and market fees. As I mentioned in the planning part of the presentation, we will have two fees defined here, a fixed fee and a variable fee. But first we need to define in what token the fee will be charged. And we will use the same EuroC for Sepolia. So here you list the network and then the address of the currency contract. In the public consume market order fee map, basically here you specify the value of the fixed fee that will be applied. In our case, for the Sepolia network and for the EuroC token, the fixed amount when an asset is purchased is one EuroC. Here you have to write the amount with the exact number of decimals used by the contract. And the EuroC contract uses 6 decimals. That's why we have 1 followed by 6 zeros. Yeah. The next variable here is public consume market fee. This is the percentage fee applied to asset consumption, and it is a percentage of the asset price. So if the asset is free, no percentage fee can be applied, of course. 0.1 means 10% of the asset price is charged as a fee. Then in this variable, a public market fee address, this is the address, the Web3 address, where all the defined fees are collected. Yeah. Next thing to define are variables related to the SSI configuration. And here we have, first of all, if SSI is enabled, in our case it's enabled, so it's set to true. Then what is the policy server URL? And I have to update it also in the other file, and I will do it after I go through the whole list of variables. Then you need to define, if you want, of course, you don't have to define a default wallet API. In our case, it's the API, the wallet that we deployed together with the verifier. And I said that you don't have to necessarily deploy the wallet, because the wallet should be deployed by the participants. In this wallet, the participants will store the deeds for their companies, will store the verifiable credentials. So normally they wouldn't trust a third party to store this information. That's why the participants should deploy their own instances. But in case there are participants who want to rely on what is provided by the marketplace, then you can specify the URL of the default SSI wallet. And in our case is this one. Then you need to set up the OK server in this variable here, public OK server URL. You specify the URL of the OK server. This will be used by the verifier. You have to define it in the market, because when we build the SSI verification string, we need to also provide to the verifier the URL of the OK server. This is how the verifier works in its current form. Then here you can also specify at the market level some default policies that will be applied to every SSI verification. And you specify, basically what you need to specify here is an URL where a list of policies are defined. And if you take a look here, for instance, at this URL, these are the policies that will be appended by default by the marketplace whenever an SSI verification is created in an asset. Okay. Going back to the presentation. Where are we? Here, Dataspace. In case you want to create, let's say, a separate Dataspace, you can specify a value here. And basically what will happen is that the marketplace will list only the assets that have this parameter set. Yeah. And when an asset is created or added, it will be created with this parameter that is set in this variable. What else we have here? Encrypt asset. This is important. Normally you want to encrypt the DDO when a new asset is created. So it should be true. Public hide onboarding module. This tells the marketplace if it should display the onboarding at the beginning or if not. And the next variable, the SSI UI URL, is also this is the wallet user interface, which is provided in the onboarding module by the marketplace. So basically, in one step in the onboarding, you have this link listed, and you can click on it to open the user interface of the wallet. So basically, this is everything that needs to be set in the marketplace. What I need to do now is to copy the file to the market directory. But I need to first I need to update the policy server definition. So let me copy that. Okay, then I will just move to the my other screen just to edit it. Mm, Okay, policy server. So the policy server no, is this one. Okay, okay. So I okay. Now everything is set in this environment file. Uh, Then let's see what's next in the deployment guide. So after we edit the file, just docker compose app -d. Okay. Uh, Docker. Basically, it will create a container using the environment variables that we set in this file, and we'll start docker ps. So it is started on this 8008 port, and normally it should be accessible through the reverse proxy in this group. But yeah, okay. So now we have the market running, and looks like the node is working as well, because these are the assets that I created earlier. And when the node started, the uh, it indexed the assets. Uh, let's give a very quick try to see if we can create an asset. Okay, let's say that allow all addresses, and we also want some policies, some SSI policies to define. Let's say that we want to check if the consumer has a legal person credential, and that's everything we want to check for the moment. Okay, service one. Service one. Uh, it will be created on this node that we deployed. The the service will basically will serve this file available here. Okay, timeout 1 day. So once you buy it, you have to buy it again after 1 day. Mm, okay, Euro C, because we use only Euro C. Continue, continue. This is the preview. Continue, and now it should, yeah, I need to connect to MetaMask first. Uh, yeah, 1 second. There's an issue with the MetaMask. It's not able to read my available my balance. My second. Yeah, you see it displays 0. Um, but it's not 0. Let's try a different account, maybe. Okay. Let's see if I have tokens here. Okay, maybe. Yeah. Doesn't read the available. Um, ah, yeah, it reads now, but I'm not sure I have enough. Let's give it a try. Yeah. 1 second, I need just to add some Sepolia to my account. And that reminds me something that I forgot to mention when I configure the node. But first, let's I just need to get some Sepolia. Yeah, I need to wait for the transaction to finish. Yeah, and what I wanted to mention while this is performed here, what I forgot to mention when you configure the node, if the node will be used in C2D environments. So basically, if the node will provide a C2D environment, you have to make sure that um, you you put enough gas in the node's account, because the node, after the node runs job, it needs to collect the money from the escrow account. And to collect the money from the escrow account, it needs gas to perform the transaction. So that's why you constantly need to check uh, if you have enough balance in the node's account. Okay, so this finished. Let's go back here. Just let's see if we have. Yeah, now we have enough tokens. Um. Okay, let's try. See what happens. Should work now. Okay, now the asset was published. And yeah, we need to wait for a while for the indexer to get to this asset and add it to the indexer's database. So now you can see it here. Yep. So this is the asset that was created. Now let's give a try to the consumption flow. So I will switch to a different account because this is my publisher account. I have a different account for consumption. And here we will test if the policy server works fine. I will not use, basically, by the way, what I mentioned earlier, I will not use the default wallet that is provided by the marketplace. Instead, I will use the one that I deployed in my environment. So I will use this one, wallet2.demo.oceanenterprise.io. This is a different wallet in which I have my DID and my credentials set. Yeah. So now I'm connected with my consumer account where I have the following. Let's just show you what I have in the SSI wallet. Here are all the credentials that I currently have, and I can use all of them in verifying access to assets because all of them are valid. So going back to the uh, to our demonstration, now I'm connected with the consumer account. Let's say that we go to the catalog. I select this asset and I want to buy it. First, I need to check credentials. Yeah. So now we will see if the link to the policy server works. And yeah, looks like it's working. Because we defined when I created the asset, I said that the consumer needs to present a legal person, um, a legal person verifiable credential. This this was read from my from my from my SSI wallet. Yeah. So I select the verifiable credential, press accept. It will move to the deed selector. This is the deed that I want to use to sign the verifiable credential when it's sent to for verification. Confirm. Now the verification is performed. Could not resolve deed. Yeah. Could not resolve deed document. Okay. Yeah. So it's working because the verifier on its side try to check my try to check the signature that was used for the verifiable credential and was not able to retrieve it, and that's why it didn't allow access to the asset. But the point here is that the entire flow from the market to the node to the policy server to the verifier and back works. And with this, I will conclude the demo here, and I will now open the floor for questions or comments.